Hi everybody, welcome. I'm Suzanne McDonald. I'm the incoming RCIScience chair, and I'm very excited about today's event. We're going to talk about aging. Aging is obviously something we all do. In fact, we're doing it right now. And in fact, people know more about aging now than we ever have before because we have the luxury of aging. The population is older than it's ever been in our recorded history. So this is a pretty important topic, and I'm very excited to host this event. And we're going to have 3 short presentations by our experts, who also happen to be friends and colleagues of mine. And then we're going to have a moderated discussion and questions from the audience. So you can submit your questions or your comments in the chat box or comments via Twitter at RCIScience or email to information@rciscience.ca. And just a reminder to be polite and respectful in the comments. We do have moderators who will be monitoring the chat box and taking action as appropriate. Now, without further ado, it is my pleasure to introduce our first speaker today, Dr. Fran Wilkinson. I've known Fran for a long time. Fran is an emeritus professor in the psychology department at York University and an active member of YU Care, which is our Aging Research Institute, the York Center for Vision Research, and VISTA, which is Vision Science to Applications at York. Over the course of her career, she has conducted research on many questions about vision and the brain across the entire human lifespan, from early development to aging. And she's also well known for her work on vision and migraine headache. More recently, her focus has turned to the interface between vision and lighting. And she's particularly interested in how recent advances in lighting technology like the LED revolution could make the built environment more user-friendly for us as we age. Among her post-retirement activities, she has given a course on light and the older eye, steps to healthy visual aging through Ryerson's Life Institute. Take it away, Fran.
Thank you, Suzanne. So I'll put my slides up. I hope everyone can see them. Yes, well, thank you everybody for coming. So I want to talk about light and older eyes. These are not normal times we're living in. Everybody's lives at the moment are a series of risk assessments. We make decisions, including whether to seek eye care based on our own vulnerability to COVID-19 and the vulnerability of those in our living bubbles. So with this in mind, my goal in this talk is to explain some of the changes that occur to our vision or to our eyes during normal aging, what consequences there are both for our vision and for our health in general, and what we can do to compensate for these changes under our current very restricted living conditions. So overall, my takeaway message from this talk is very simple. Our goal should be to make vision as effortless as possible for our older eyes. I'm going to leave discussion of cognition to my colleague Dale, but to suffice to say that badly degraded input can't help but pose an added challenge for our cognitive processes. My second message is that light is our best friend in achieving both the goal of effortless vision and better health in general. I'm going to limit my discussion today to normal aging, but of course there are eye conditions that are not normal. And I can try to address questions about some of those in the question period if there's time. So to talk about light in the eye, there's 2 properties of light that we have to understand. The first is wavelength. So here is the visible range of light going from 400 nanometers to about 700, and the perceptual correlation with wavelength is color. The second property of light that's important is its intensity, and the correlated percept there is brightness. And the human visual system has an incredible range of intensities that it can respond to. In fact, a factor of log unit 10 to the 13 range, which is enormous, although we don't do this all at one time. So our visual system adjusts to ambient light levels. So we're not normally aware of how huge these differences are. But as you can see in these pictures and the measurements I made when I took them, the amount of light available at our eye and outside in a daylight situation could be as much as 10,000 times more intense than what we see, for example, in the office that I'm giving you this talk from. So the human eye uses light for two different sorts of things, and I'm going to try to address both of them today. The first is for vision, obviously, and the second is to synchronize our circadian or 24-hour rhythms. So let's start with vision. For vision, our eye acts somewhat like a camera, producing a focused image here at the back of the eye on the retina. This is a blow up of a little piece of the retina. And the retina is like the digital sensor in a modern camera. Our photoreceptors here capture the light, turning it into nerve signals from several million individual receptors or points on the retina. So like our camera, we have megapixel vision. These signals are sent from the eye through the optic nerve to the brain. And this process seems very effortless, at least for younger eyes. The effort comes in at the higher levels of cognitive processing, where we have to decide whether we actually recognize the face we're looking at or what that movement was in the bushes. We have another group of photoreceptors, and these send signals measuring light on the retina to a tiny part of our brain on the underside of our brain called the suprachiasmatic nucleus. And this information is used to synchronize a whole range of our body functions that have approximately 24-hour rhythms. The most obvious of these is our sleep-wake cycle, which is determined in part by fluctuations in a hormone called melatonin, which you can see here. It reaches its peak in the middle of the night and is at its lowest during the daytime. And if we get too much light of the wrong wavelengths, especially short wavelengths in the middle of the night, we'll have trouble sleeping. And if we get too little during the daytime, we may be very drowsy. So melatonin and several other hormones, along with body temperature, blood pressure, and various other functions, all work on a 24-hour cycle. But without the synchronizing effects of light, they can fall out of synchrony, causing a wide range of problems. And here I've listed some of the problems that people have been studying in recent years that are linked to poor circadian entrainment. And I just want to emphasize the first two, because we've been hearing a lot lately about how people are suffering from both sleep disturbances and depression during this COVID lockdown that we're all going through. Now, I want to just show you very quickly the photoreceptors, and particularly to talk about the cones. The rods, these skinny ones, operate under low levels of illumination at night. The cones, of which there are 3 different sorts, operate under higher illumination, and they provide the basis for color vision. If you look over here on the right, you'll see that each of those cone types has a different range of wavelengths that it's sensitive to. And each of them has a peak sensitivity at a particular point on the spectrum. So one peaks in the blues, one in the greens, and one over in the yellows towards red. And I also want you to notice that the blue sensitive cone is much less sensitive overall. It absorbs a much smaller fraction of light than the other two. Now here we have the photoreceptors that I'll call the melanopsin cells. Their official name is intrinsically photosensitive retinal ganglion cells. And I had to draw them into this diagram because they were actually only discovered in 2002, whereas the others we knew about a century ago. So these are the cells that register overall light level. So having said all of that, one more thing about those. I just want to point out that their peak sensitivity is also in the short wavelength end of the spectrum, down near the blues. And that will be important in a few minutes. So now turning to aging, I want to just mention some of the major changes associated with aging in our eyes. The first one, I'm sure we're all familiar with, anyone over 45 is, this is presbyopia, the fact that it becomes more and more difficult to focus on close objects. And that's because the lens in our eye gets more and more stiff and we can't change its focus. The ones I want to focus on today, though, are these 2 points, that the eye gets increasingly little light coming into it as our eyes get older, and the neural processing slows down somewhat, so that we are slower at adapting to changes in lighting. So if we go from light to dark or from dark out into bright sunlight, that takes longer to adjust. And I want to focus on those two things right now. So why is there less light getting into our eye? Well, there's several reasons for that, but I'm going to focus on two of them. The first one is changes to our lens. Not only does the lens of the eye get less flexible as we age, but it also starts to yellow and it becomes more dense. So less light goes through it, and that light that does come through is from the longer wavelengths, more in the yellow range of light. In extreme cases, we may develop a cataract, and that will cut down the light even further and will also scatter the light, so it will become very difficult to form a sharp image on the retina. The other thing that happens is our pupil size changes, and this is quite a big effect. So this graph shows you changes in pupil diameter with age from 20 to 90 years, and you can see that those changes are particularly big for dim light. And I show that down here in terms of the area of the pupil. So while the differences aren't too big under bright light where we want to have small pupils, under dim light where we're trying to get a lot of light in, the younger eye is getting a lot more light than the older eye. And in fact, the light levels in an older eye may end up being as little as a quarter of the amount of light we're getting in a younger eye. So that's a big change. And many older people are aware of this, although they may not know why. So they'll tell you, my house seems very dark these days, or why is this restaurant so dark? So because the lens yellows, that also has an effect on our color vision, as you can see here. So while these colors are just a little less intense, down in the blue range, it's actually hard to see color at all because yellow filters are filtering out the short wavelength light, which we're not very sensitive to in the first place. So you can see here that colors are less intense, and we see purples and say the blue in my sofa as blacks, and it's hard to distinguish our black clothes from our blue clothes, and many older people will experience this. It's important, though, to notice that those melanopsin receptors are also down in that range, so they too are going to be selectively deprived of light by this yellowing of the lens. Secondly, because the overall light level is reduced, this is going to affect vision in some other ways. So in this figure, if you move from the top to the bottom of the figure, you have increasing contrast. That contrast is the difference between the lightest and the darkest point in the image. And as we move across the image this way, we have finer and finer detail. So in normal vision, you can see that there's an area that we can see, which is best in the middle range. And then as details get finer, we need more and more contrast to perceive them. What happens when we reduce the light? Well, this simulates that effect. And now you can see that we lose the fine details completely, and we need higher contrast. We need to be down at this part of the image in order to see differences at all. So this is sort of a simulation of what might happen with an older eye under normal lighting, or a young eye if you were to test them under very low levels of illumination. So I want to spend the rest of the time giving you a little toolkit for how to deal with these changes to our eyes. First of all, it is really important to try to get a daily dose of daylight outdoors if at all possible, because as you saw at the beginning, the intensity of light is much higher out there, and your circadian system really needs that light. So even if it's only for a few minutes, try to get it in the morning. That's when it's most important. Try to get some real daylight. And if you can't get outside, then be very close to windows, because you don't have to go far into a room for that illumination to fall down to very low levels. The second thing I'd say is try to improve your task light. This light provides general illumination, but you can't tell at all what's down here underneath it. In fact, with a nice task light like this little one that I got from IKEA for 10 bucks, you can actually see my CD collection and read the titles. Another useful thing to do, even though we are attached to our newspapers and books, is to consider switching to a self-illuminated, take that off for the moment, tablet, because with a tablet we can scale the size of the fonts and we can change the brightness, and so we can get a much higher contrast image. And here's a case that I think is really important. Drug companies seem to put all the critical information into minuscule type on their pill bottles. But you can use either a magnifier with a light, which I'm sure you can buy on Amazon or from the CNIB, or you can use your cell phone to take a zoomed in picture and then zoom that in even more so that you can actually read these critical instructions about what these drugs might do to us. Turning to the slower adaptation I mentioned to changing light levels, one thing I suggest is transition lighting. So if you're going to be outdoors in bright daylight, it's a good idea to leave the hall light on so that when you come inside into your dark house, you have a period of transitioning into lower light levels before you're in really dark conditions. Secondly, strongly recommend that you go around your house and eliminate obstacles, especially on what I'll call the bedroom to bathroom route, which all older people will understand. So it is not wise for me to leave my cell phone charger on my carpet, and similarly any other difficult to see objects. It would be a good idea to keep them removed. Finally, I can't emphasize enough how important I think it is to use night lights, because during the night we don't want to light adapt our eyes. We don't want to go into a different room, turn on a bright light, and then come back into a dark bedroom where we really won't be able to see anything. If we can keep an overall low level of illumination along any path we're likely to take, that is going to significantly reduce our risk of a fall. And in these pandemic times, the last thing we want to do is fall. So now turning finally to presbyopia, the only thing I want to say here, we know that glasses, reading glasses, progressives are the thing that will help us. I just want to emphasize that your prescription belongs to you. So if you need new glasses, you're perfectly in your rights to call up your optometrist and ask for your prescription. If they can't provide new glasses and you have to buy them online, that is better than nothing. And I suggest you use either light dark contrast or else bright colors to help you find things easily when you in situations where you might not have your reading glasses. So here's a drawer from my own kitchen, and you can see that my favorite cooking tools I can easily pick out because each one is a different color. My spatulas, my scissors, my measuring spoons. And sometimes we can't use our glasses at all, like in the shower, for example. I'm sure you've all had this experience, either at home or in hotels. You take off your glasses and you have no idea which of these bottles is which. So sometimes we have to give up our brand preference in order to be able to use color to see things easily and to make our vision a little more effortless. So having said all that, my final messages are these. First of all, if you already suffer from an eye disease, it is really important to continue your treatments or medications during this pandemic. So if you have glaucoma or diabetic retinopathy, for example, be sure to stick to your treatments. Sudden big changes in vision are not normal. So if you suddenly lose vision in part or all of your visual field, if you suddenly experience extreme blurring, if you suddenly have the onset of flashing lights and they don't go away, or if you suddenly have very intense eye pain, especially if it's accompanied by nausea, these are all signs of serious medical problems, so you will want to seek medical attention. Also, remember that every pair of eyes is different. We age at different rates, and the changes I've talked about happen at different rates in different people. So you need to be your own vision scientist and try out lights and try out changes to your environment that will help you see better. And finally, never say it's just part of aging. There's nothing I can do about it, because actually, usually there is something you can do about it, and I encourage you to try. So saying all that, I just want to show you a few websites which you'll be able to access later that provide a lot of information about the eye and aging that could be quite helpful, and say thank you for listening.
Fantastic, Fran. Thank you. That toolkit is super cool. Excellent. Well, if you have questions for Fran, make sure that you put them in the comment box or email them or tweet them or whatever you have, whatever you want to use, and we'll talk about them at the end. That's terrific. So it's my pleasure now to introduce our next expert, Dr. Dale Stephens. Dr. Dale Stephens is an associate professor in the Department of Psychology at York University. He's the director of the York MRI facility and the Cognition and Aging Neuroscience and Neurointervention Lab, CAN. He uses a combination of a lot of neuros, so neuropsychological, neuroimaging, neurostimulation, and neurofeedback techniques to study large-scale brain systems and processes that underlie higher-level cognition in humans, how these are affected by healthy aging and neurodevelopmental disorders, and also to develop neurointervention strategies to enhance cognitive performance. He's also a pretty decent pool player. Over to you, Dale.
Thank you, Suzanne. And thanks, Fran, for an incredibly engaging and eye-opening talk. And thanks to everybody who's here listening and RCI for inviting us to be part of this panel. I'm really excited. I think we have a good lineup where Dr. Wilkinson started from lower level perception and how important seeing and eyesight perception is in aging. I'm going to be talking a little bit about sort of more higher level cognitive aspects of cognitive aging. And then when we have Dr. Gary Turner at the end, he'll be moving towards more sort of social aspects that relate. And we're all talking about ways that we can try and mitigate or, make some of these declines that we think about in aging a little bit better. Okay, so with that, I am going to talk about a lot of neuro things today. And hopefully by the end, that won't be confusing or such a mouthful. So reversing age-related cognitive decline, that's sort of the goal of what we're working on in my lab and with some of my collaborators. And we use techniques of cognitive neuroscience, including neuroimaging, neurostimulation, and neurofeedback. Okay, so just a quick roadmap of where I'd like to go in my talk today and the time that I have. First, just sort of a quick summary of what do we know about cognitive aging. And I'm going to talk about the fact that we know some aspects of cognition decline, but there are other aspects of cognition that improve. And in general, we can look at it as a shift in our cognition. And I'll say more about that. Well, what do we know about the aging brain? Well, a lot. We've been using neuroimaging, so something like functional magnetic resonance imaging. That's what I will talk about. To really, we have incredible advanced tools now where we can look inside and sort of see the activity of the brain and the real living human brain in real time or in complex models. And what I look at are changes in these large scale brain networks. It can be complicated. I want to try and break that down to a fairly simple story, I think, that relates to cognitive aging. Last, once we talk about changes in behavior and in the brain with aging, what can cognitive neuroscience do about it? Is there anything we can do? So I want to talk a little bit about some of the experiments and initiatives we've been working on in my lab, where we're trying to modulate brain networks using the tools of cognitive neuroscience to enhance cognition. And one stream of research, this is using non-invasive brain stimulation, something called transcranial magnetic stimulation. And another line of research, we're doing what we call neurofeedback training. Okay. So to jump in, what do we know about cognitive aging? Well, I think a lot of us fear as we get older that, aging just comes with this consistent sort of slow or maybe rapidly increasing decline across a lot of different aspects of cognition. A lot of us think about memory and attention. And there are some reasons to be concerned about it. This is a very famous seminal study, fairly old now, but that looked at a number of different kinds of cognitive tasks. Now, if you look at these graphs, there are 4 of them here. Each one of these graphs shows a line that represents how well a group of adults are performing on a task. And these are several different tasks that are all related to processing speed. Here are some tasks with working memory, long-term memory, and short-term memory. And so, the higher you are on this scale, the better you're doing, and the lower, the worse. And as you can see here, these are the decades of the participants in the studies from the 20s to 80s, right, on each of these studies. And so we see that across some of these domains, there are sort of linear declines in our general performance on these kinds of tasks. And we can see, though, that they start around, in the 20s. I mean, we get a little bit of an increase in decline in the later years, but this is just a natural part, typical healthy aging. And it can be a concern, but that's not the whole story. There are aspects of cognition that, in the absence of some sort of pathology, like a neurodegenerative disease or dementia, can improve across the whole lifespan. So this is knowledge-based verbal ability. So verbal ability and just general knowledge of the world. concepts and our understanding of things. That expected decrease across the lifespan. So really the way to characterize this would be really a shift where there's more of a shift as you age from what includes declining fluid cognition, we call it, but preserved crystallized cognition. So fluid cognition are those tasks where we need novel information, learning new associations, or fast, in the moment, flexible kind of cognition, fast, flexible cognition. Whereas crystallized cognition relates more to sort of retained, stored knowledge and understanding of the world across the lifespan. And so there's a shift between these functions. Okay, well, what do we know about the brain? A lot of what we know about the brain and aging comes from functional MRI. Now, this is a magnetic resonance imaging machine here. We have one here at York University. And functional MRI is the ability to look at a marker of brain activity. So we can actually get an idea of what parts of the brain are engaged or active or are communicating when people are doing different kinds of cognitive tasks. And if we look at it from this large-scale brain systems or network perspective, it can get kind of complicated. But I think we've been talking about something we think of as a fairly simple model. We call it the three-network model, or 3-net, which actually can explain a lot of what we see in cognitive aging. So I'm going to try and break that down in a way that makes sense out there today. And I'm going to talk about just these 3 networks. One that we call the attention network, one we call the default network, and one I'm going to call the control network. Okay? So a little more about these. Well, what you can see here, this is the 2 networks put onto a surface of a brain. This is basically looking at a model or image of somebody's brain that was taken with an MRI scan. So all these regions that you see in blue here are part of this default network that I mentioned here. And all these regions in red you see on the brain are part of what we call this attention network here. And what we know is that the attention network is critically important for when we are focusing on the external world. We're looking out in the environment around us. We need to see things, we need to act, take in information, navigate, hear what's going on. Anything involved in focusing out there in the perceptual environment involves the attention network. But another very important part of human mental life and our survival in the world is the ability to introspect. That is to look inside the mind. That involves retrieving memories, remembering things, drawing on our knowledge, trying to remember our plans and goals. What am I doing right now? If I'm going to the store or am I going to work? All of these things are internal representations. And we need to be able to simultaneously toggle back and forth or integrate information from what's going on around us out there in the perceptual world to what we know about the world, to how to understanding the things that we see based on our memory and activating our plans and goals as we move about the world. And so how do we think that we do these things? So we see that these networks are anti-correlated. If we look in the brain, when one of these networks, say the red network is all active and the neurons are firing and we see a lot of signal in the MRI, the blue regions, the default network is very suppressed or very low, it's not active. On the flip side, when we look inward or we're trying to remember something or we're trying to imagine what we'll do in the future or make plans, the regions in blue or the default network becomes very active and the red regions or attention network becomes deactivated. I'm going to bring in one more network called the control network here, and that's down here in green. We think of this network as being sort of the seed of our higher volitional control, our ability to direct our focus where we want. So we're not at the whim of things popping up in our environment or random memories and thoughts coming up. We actually have some control over where we're focusing. So this control network, we think the job of this is to toggle back and forth and engage either the default network when we're doing internal cognition or the attention network when we're paying attention to the world around us. To summarize that, here we go. Putting all these networks, this is how these networks look like when all in the brain together. So again, the blue regions are default network involved in internal cognition. The red regions are involved in external cognition. And these green regions they become active and they couple with the default network when we're thinking internally, or they let go and they couple with the attention network when we're looking outward. So it toggles back and forth. Well, what happens in aging? We know that the default network, which I've been mentioning, seems to be particularly susceptible to some age-related decline or even Alzheimer's disease pathology in an extreme case. This is what we've talked about as the default network. You can see if you look at amyloid deposition, which is a marker of brain lesions in Alzheimer's, it looks like a similar pattern. We look at regions of the brain that shrink a little bit in Alzheimer's disease, or where we see metabolic disruption. The pattern looks very much the same here, here, and here. That's where we're going. So the default network seems to be particularly susceptible. We also know that there's a reduced suppression of this network in older adults when they're doing an externally focused task. So a lot of time in the laboratory, we're engaging people in some sort of a task where they're looking at images and making responses. Of course, this happens in the real world as well. And in a typical young brain, what we see is that the blue regions become very suppressed when we're doing an externally focused task, and we see these bright regions coming online. We look at an older, a brain of older adults, or even people who are suffering from dementia. What we see is we don't see that decline or that suppression of the blue regions. We see a lot more activity in the brain. Well, what does this mean? Again, what we think it means here, and a lot of this work is actually done by Dr. Turner, who will be speaking next, and his colleague Nathan Spring, something they call the default executive coupling hypothesis of aging. And that is that there seems to be a sticky or an increased link or a stable stuck link between the control network and the default network. Now, this might reflect the fact that older adults rely much more on their crystallized cognition, their semantic knowledge, that sort of lifelong built-up knowledge of the world and facts. Or it might represent something maladaptive about the brain. And so that's something we need to understand. So what is the relationship between what I've said about the brain and what we said we saw about cognitive activity? Well, the idea here is that as we get older, there seems to be an increased linkage or a fixation between this control network and the default network, which involves accessing our stored knowledge, thinking inward or making plans. And so to the extent that that happens, that might be some of what's responsible for or related to decreases on these fluid cognitive tasks, but increases in these crystallized tasks. Okay. So what can we do about it? I want to talk about two examples of how we're trying to modulate large-scale brain networks to try and enhance, or what we'd like to say, we would like to reverse age-related cognitive decline. So it's a tall order, and it sounds kind of bombastic and ambitious, but I think we're making some traction here, and I think it's possible, and we've got some early evidence to show that we can do this. And again, I want to talk about a couple of really exciting sort of cutting-edge tools that are available to cognitive neuroscientists now that allow us to not only look inside the living, thinking brain, like neuroimaging, but also to actually have some sort of effect on it, to modulate the activity of the brain, modulate the activity of these networks, and potentially have a beneficial effect. So the first thing I'd like to talk about is it's a non-invasive brain stimulation, and it's called transcranial magnetic stimulation, or TMS. So this is a picture from a setup in my laboratory. There's a chair, it looks kind of like a dentist chair, but it's a nice comfy chair for a participant to sit in who's not there. We have something, this is just the coil. And in the end, these are not extremely complicated. It's a figure of 8 with 2 round coils. And when you pass some electric current through there, it causes a magnetic field. So this is a mock-up of a coil against the side of somebody's scalp here. And that magnetic field crosses the skull and the scalp and has an effect on the neurons in the cortical surface just there under. And it can actually, what it can cause is an increase. It can potentiate electrical firing of the neurons there, or it can suppress it and introduce noise into the system. So the idea here is that what we can do, and it's you don't really feel anything. We consider it non-invasive because it's just a coil held on the surface of the skull. But using something called neuronavigation, we can get images of a brain and use a computer model and cameras to determine exactly where in the brain we're stimulating the cortex. Okay, and if we can do that in a non-invasive way, maybe we can, actually affect some changes in the brain that might improve cognitive performance or help, reverse age-related cognitive decline. So a very good colleague of mine who works at Harvard Medical School named Mark Halko had a seminal study showing that here's an example of a brain here. So this is like the left side of somebody's cortical surface, and this is sort of the medial, as if you split the hemispheres in half and look at the medial surface. These orange regions are what we call the default network, which I've been talking about. And he showed that if you actually isolate a particular node of that in individual people and take a TMS coil and, of course, put it just outside the head and you stimulate regions, depending on where you stimulate in the brain, you can get different effects. So this down here looks like a small brain. It's part of the brain called the cerebellum, which is right back here, bottom of the What he showed was that you stimulate this region with a particular kind of frequency of stimulation. You see these blue regions here. That's part of the default network that you've now suppressed the connections. So within this default network, you can actually quiet down the activity and sort of suppress the communication across that network. If you stimulate a different region with different frequency, you can actually enhance or increase activity of the default network. So not only are we sort of affecting the spot on the cortical surface that we're stimulating, we can have effects that spread throughout brain networks. This is a very promising technique. Okay, so I just want to show you what we did with this. We have an early experiment with some preliminary results that are very exciting. So again, this is a brain that shows the blue is the default network, the red is this dorsal attention network, and the green is called the control network. We used MRI in a number of younger and older adults to isolate this critical node. This is called in the parietal lobe here. And we decided to target the same spot, as close as we could, the same spot in each subject's brain with TMS to see if we could affect, network level changes in a way that might be beneficial. And here's some results of what we found. And so I've got a little lightning bolt to represent where we stimulated. Of course, not a lightning bolt, but a mild stimulation here. So when we did this with young adults, we see this is blue regions are part of this default network here. We stimulated there. I'm going to walk you through quickly what happened. So this scale shows you how high the activity was. So we stimulated the brain, and then we went and put them in an MRI scanner and said how active or how much of these networks communicating after we stimulated the brain, because the effects last. So the blue bars are what they looked like before they had stimulation, and then we stimulated the brains, put them back in the MRI scanner. What you can see is there was a decrease in functional connectivity and activation in the default network in these young adults. So this stimulation decreased default network activity. What it also did was it made a change to how this default network was talking to the control network. So from here to here, you can see these regions change. Okay? And that was interesting, and probably not something that's going to help someone perform a task. However, we were targeting older adults because we wanted to change this idea where older adults don't suppress this default network and seem to not to be able to switch between their external and internal cognitive focus very well as well. So same thing, we stimulated this same brain region in a number of older adults, and we saw something very striking. So what we showed here are two regions of the default network, here and here. And in both instances, the solid bars show what the brain looked like before stimulation, and then what that default network looked like after. And what we're showing here is that we actually were able to increase the integrity and connections of this all-important default network in the older adults. Maybe more importantly, though, when we looked at the connection between the default network and this attention network, we saw that there was some slight connection there where they should be pointing in opposite directions. So what happened after we stimulated these brains and these lines here was that it decreased the connection there. So this actually is exactly, we changed the pattern of brain activity a little bit so that it looks much more like a younger brain. Now, some preliminary data also showed that these older adults were able after this to produce more details of memories in a memory test we were doing in the lab, which I don't have time to go into great detail. Okay, I want to shift gears now and say that was an interesting effect that we had in the laboratory. And we are looking at developing sort of neurointervention techniques that might work out there in the real world. But I want to switch gears and talk about something where we are trying to do that now called neurofeedback training. And this is kind of a simple idea. This is just a little drawing here of an individual who's got some kind of a system on the head that can measure what we call EEG, which is electroencephalography. And this is, these are electrical waves that you can read outside of the scalp, that reflect underlying neural activity. And you can see this with people using things like lie detectors or looking at sleep cycles where you have the needle on the page. Okay, so we know something about that. You can read those signals and then actually take that information and feed it into some sort of a machine. Like in this case, this is a mobile application like a smartphone or a tablet, and have that information somehow sent back to the individual. It's sort of a positive feedback loop. They can actually learn to increase certain kind of brain activity, to increase activity in certain parts of the brain or decrease certain parts of the brain. And it's done through an implicit learning technique. Okay? So the user can, brain activity, they can modulate their own brain activity, and it's done through implicit rewards or deterrence. And so you start forming an association between a particular behavior and a consequence. So I'll say a little more about that. An example would be, I'm reading brain activity, and my goal is to try and increase a certain kind of brain signal that I know shows that you're engaging your control network more, which can help you focus and have better memory. And that is a signature. Well, the more that your brain is showing that activity, then maybe you have some sort of feedback that gives you a reward saying, hey, you're doing well. And if that activity starts to suppress, then you get a signal saying, hey, it's not doing as well. And over time, even if you're not sure how you do it, you learn to change the brain activity in your brain. And this works for almost everybody who tries it. The problem is that early studies showing that you can use this to enhance cognitive performance, like memory and attention in older adults, is very much laboratory-based. And that's an intense, very sort of complicated setup that takes a long time to go into a lab. It takes a long time to set up. So this is an example. It's not really practical to bring people, necessarily bring people into the lab daily to have these kinds of sort of training sessions. So I'm working with a company that's developing mobile techniques. So nowadays, there are these cool headbands you can buy that measure EEG, electroencephalography. You can wear walking around in the world, and you may have seen people wearing these things. One system is called Muse. There are other kinds. You can buy them in stores. Now, these things pair with a smartphone, like an iPhone or a tablet, And I'm working with a company called Excensa Labs who developed software that reads this information and builds it into kind of like a little video game device where you're watching yourself biking through the mountains of Corsica in Italy. Beautiful scene. And so the more you ramp up a particular kind of brain activity, the faster the bike goes and the more beautiful the scenes are and the more the music is nice. And if you're not doing the right kind of brain activity, it kind of slows down. And over multiple sessions, the idea is that people should learn to amp up a certain kind of brain activity. Now, the ultimate idea here is that it's like going to the gym. When you go to the gym and you say do curls to work on building up your biceps, the goal isn't usually just that you're better at doing curls in the gym. The idea is that you improve your strength. It's going to help you in lots of aspects of life. It's the same way here. This exercise is supposed to have lasting effects that then should have generalizable benefits in other kinds of tasks. Okay, so it's a real-time neurofeedback you can do in the comfort of your own home or a coffee shop or wherever you are. Okay, I just have a couple more minutes and I'll wrap up. I want to show you some preliminary studying results from this on a graph here. So this represents 24 training sessions. We had 28 people doing the neurofeedback training with the headset, and then we had 17 control or what we call sham subjects who were getting feedback that wasn't actually related to their brain activity to see if we got improvements. The first thing we noticed that this red line shows the sham people who weren't getting real neurofeedback training, and their brain activity kind of stayed the same and went up and down from session to session. If you look at the blue line here, this is the activity of the neurofeedback training group, and it has increased at almost every time point, showing that they were able to use this feedback to ramp up this kind of brain activity, which we think of as being related to the control network. Okay. Well, how did it affect their memory? Well, we also tested them on some memory and attention tasks before they started training. They then did 24 training sessions, which were about 15 minutes long, mostly in their own home, over a couple of weeks. And then we tested their performance again. Okay, so we had measures of attention. One is alerting, how fast can you just alert your attention to something? One is how well are you able to alert your attention to the right spot in space when you're cued? And conflict is how well are you able to attend to something when you have competing or conflicting information? Okay, so the blue lines, the red lines here represent the sham group. We didn't get real free training. And as you can see, from before and after training in each session, they stayed about the same. These red lines are flat in pre-post. However, the blue lines show the neurofeedback training session. And in each of these, there was some benefit. So when we tested them before neurofeedback training versus after, they got better at alerting, they got better at orienting, and they also got better at conflict resolution. The reason this line goes down means that they're not being affected as much by the conflict. So in these three measures of attention, there's preliminary early evidence that we're improving attention. Now, this is measuring them on an attention task about a week or two after they finish their training. Finally, we looked at verbal fluency, which is an ability to access your knowledge and your verbal structures. And again, if we look at the sham training subjects, they got a little bit better from practicing before to after training. But this neurofeedback group had a huge boost from before to after the training. They got much better at doing this verbal fluency test. Finally, we looked at a working memory test and had some more effects. Just from having done this session twice, this is time number 1, time number 2, the sham group got a little better, not significantly so. The group that got neurofeedback training between this bar and this bar, they improved a lot on their memory. And so the take-home message is that some aspects of cognition decline in aging, while some improve across the lifespan. There's this shift from fluid to crystallized cognition. Changes in large-scale brain networks are associated with these changes. We know that. And these changes, it has to do with changes in the interaction of these large-scale brain networks. Well, what can we do about it? We're developing neurointervention techniques that can modulate these brain networks and potentially reverse some of these age-related cognitive declines. We're doing that with non-invasive brain stimulation, like TMS, in the laboratory at this stage. And now we're doing neurofeedback training out there in the real world and having some really exciting initial results. So with that, I will end and thank all my collaborators who worked on these projects listed here. And I want to thank RCIScience for putting on the event and inviting us. And thank you, the audience. And I will turn it over. Thank you.
Great, thanks, Dale. That neurofeedback seems like science fiction. It's amazing. Thank you. I'm sure lots of people will have questions about that. So again, submit your questions in the chat box and we will try to get to as many as we can. And now our last speaker is Dr. Gary Turner, who is an associate professor in the Department of Psychology at York. You're seeing a theme here. Everyone's at York. And he is a registered clinical neuropsychologist in the province of Ontario. Gary's program of research investigates how age-related brain changes impact cognitive and real-world functioning, including financial decision-making, both in normal aging and brain disease. A core objective of Gary's work is to leverage neuroscience discoveries to guide the design of more effective interventions towards sustaining cognitive and brain health, ultimately helping older adults live healthier longer. Take it away, Gary.
Great. Okay, thank you, Suzanne, and thank you to RCIScience for the invitation, and thank you for all of you for joining. So I think this has been a great session so far. As Dale mentioned, what we have covered here, I think with Dr. Wilkinson or Fran covered perception. You had a really beautiful talk from Dr. Stevens or Dale. I'm going to refer to him as Dale and Fran going forward. But so Dale's talk took us up from perception up to cognition. And I'm going to, as Dale mentioned, I'm going to kind of take us more out into the real world, where I'm going to draw on some of this earlier work and bring it together and talk about something that is happening in our everyday lives. And what that's going to be is financial exploitation and aging. And I called it surveillance to intervention. And that effectively is my roadmap. So I don't have a roadmap for you. I'm going to talk about surveillance in the first part of the talk. And then I'm going to talk about intervention toward the end, kind of some of the directions that we're going to take on the intervention side of things. And you'll see as we go forward, how I'm going to do this is I'm going to kind of take numerous ingredients from cognition. I'm going to talk about social functioning, and I'm going to talk about the brain. And we've heard a lot about the brain already, but I'm going to talk about some of our own work in the brain that looks at how these all come together to alter financial exploitation risk in older adulthood. So that's my roadmap. It's essentially surveillance to intervention. I am going to start with my collaborators and funders on this work. So I always do this because I typically go over time and then I rush through this, but this is such an important part. None of what we do is ever on our own. So I'm working with an amazing team of collaborators, Nathan Sprang at McGill University, Natalie Ebner, who's at the University of Florida, and Bonnie Levin, who's at the University of Miami. And also a big thank you to the funders from our institutions, our universities, as well as the funding agencies, as you see listed here. So thank you to them, and you'll hear these names come up again as I go through the talk today. So what I'm going to do to start off, I want to talk about the scope of the problem. And so I think most people in the audience have become aware of the perils of financial exploitation, and that includes scams and frauds and whatnot. And I'll talk a little bit more about types of financial exploitation in a few moments. But even when I started this work about 5 or 6 years ago, it was already being described as a public health crisis or a virtual epidemic, as you see kind of the quotations I put up there. It was being written about in popular media. You probably see it's only growing from then. And back at that time, and even going back maybe a decade, the estimates were that 1 in 5 adults over the age of 65 are falling victim to some type of exploitation or fraud. So we're at about a 20% level. And that's costing. That comes with enormous costs. So I put $2 billion there, which was an estimate. Again, it might be about a decade ago now. So that's certainly grown over the last decade. But that's likely a severe underestimate of the problem. And the reason why is that these are typically self-report. So what we're doing is actually asking people, have they been victims of fraud? And I think we could all probably get the sense that if someone's going to ask you that, you may or may not be willing to share that you were the victim of fraud. So we believe, and I think the field in general believes, that this is still an underestimate of the true prevalence of the problem. I also think this is going to get much bigger and has gotten much bigger as a problem. And the reason why is really twofold. So one is that we've all heard of the baby boomers. We're all part of the baby boomers. We're kind of on one end or the other. So if the baby boom generation is moving through in terms of getting older, and we know this in North America and Canada and the US, there's a huge cohort of adults who are moving into older adulthood. What you probably don't think about as much, and certainly this is not universally true, but as a cohort, they're the wealthiest generation in human history. So you can begin to start to think, well, if they're the wealthiest generation in human history, then perhaps that might you might think of them as a bigger target for fraudsters or people who are willing to perpetrate financial crimes. So that's one reason why I think this problem is growing. The other reason is that the avenues for financial exploitation are broadening. And if you think back and we go back to kind of say the middle of the 20th century, in the 1950s, for example, or 60s, probably the chances of financial exploitation or fraud were more or less limited to the salesperson who came up to your door and tried to sell you something you didn't want, a vacuum cleaner, a subscription, something like that. Now, of course, if we fast forward, we probably all received the phone call from the CRA, from the revenue agency that says, you owe us money or what have you. So we've all gotten those phone calls. So that's another avenue of financial exploitation. The third, and obviously, and I'm sure you know where I'm going with this, is the third biggest avenue now, or an emerging avenue, maybe even the biggest, is online. So more older adults are living their lives online, as we all are. Everyone is living their lives, especially now in these pandemic times. Everyone's living their life online, kind of what we're doing right at the moment. So you may think, or there is unfortunate stereotype that older adults are not living their lives as much online. I can tell you flat out that is not true. So we have data from a cohort in Montreal where we asked them how much they're spending time online. Fully 97% of older adults, average age 75, thereabout, 97% of them are doing activities online, whether it's social media, whether it's email and whatnot. So the stereotype of the older adult being afraid of technology and not going online is not true. So now you can start to see that there's another avenue for financial exploitation that's emerging. And we're starting to do some work in this domain. I'll talk about that toward the end of the talk today. So I hope I convinced you that this is becoming and has been and is growing into what was described earlier. There's a public health crisis and perhaps even a virtual epidemic. So now I want to move into the exploitation risk factors. So remember, our goal here is surveillance. So if we're doing surveillance, we want to identify those older adults who are at greater risk of exploitation, so that then we can kind of begin to think, we can start to think about more targeted intervention measures that I'm going to talk about at the end of the talk today. But think about surveillance. In order to surveil properly, we have to know what is going on, what is leaving some older adults more vulnerable than others to financial exploitation. So I'm going to go through some of these here, but before I do that, I want to talk again about another possible stereotype. So I want to be careful here. And so the stereotype is that of an older adult who is the stereotype is all older adults are vulnerable to financial exploitation. That is fundamentally not true. So, and that's not the point of our research here. So I want to kind of combat that stereotype right up front. So I certainly don't want to promote that stereotype. There are amazing older adults who are doing making incredible financial decisions and so on and so forth. The goal of our research program here is to identify those older adults who may be at higher risk than others for financial exploitation. So I want to kind of address that. So everything I talk about in the talk is about differentiating older adults and identifying or doing surveillance so that we can identify those who are at higher risk than others. So I'm not making the statement that older adults are all, as a cohort, vulnerable to exploitation. Okay, so what might be some of the risk factors? If we're going out to surveil and figure out who is at higher risk, what do we want to look at? So Dale, I was going to say Dr. Stevens, but Dale just gave us a really beautiful overview about cognitive changes that occur. And he drew out the two distinctions that I always make also. There are some processing skills that are relevant for decision-making, financial decision-making, that decline. Their processing speed, episodic memory, some of the other factors that Dale walked you through. And those absolutely will interfere or compromise ability to make good financial decisions. But, and I've highlighted here, greater life experience may also help in this regard. So just as Dale was saying, the story is not all negative, we do know that older adults gain a larger repertoire of skills and experience that can help them compensate for the processing abilities that may decline with age. So I think that's an important and positive and nuanced way of thinking about late life development. And so you got to think about it as some things decline, but remember, life experience is increasing. And there's some beautiful research now that suggests that older adults can indeed bring their life experience to bear to make better financial decisions in some contexts than even younger adults. So this is a big one, and we all know why, living in COVID times. We believe that social isolation, and there's some good evidence now from our work and others, that social isolation is exacerbating exploitation risk, financial exploitation risk. And I won't go into this in detail. This is work that's ongoing in our laboratory, particularly around COVID. We're collecting data over the COVID period. But how I'm going to frame this is that the best financial decisions, particularly the big life financial decisions, are made with the consultation of people around you, people who you trust, family members, friends, people who are in your circle. And so when you're isolated from those people, it increases your exploitation risk. I think that's something that we all have to consider, particularly in these times. This is a really interesting facet of changes that occur in normal aging. Remember, just like Dale and Fran, I'm speaking about normal aging here. There is an increased trusting behavior as we age. And so there's been also some beautiful work that's come out in the last couple of years that have talked about older adults are more naturally trusting, and they have more difficulty than younger adults in distinguishing trustful from untrustful behaviors and to learning to make that distinction. And in one recent study, it was particularly fascinating because older adults actually demonstrated rated financial advisors trustworthy, even though the financial advisor had actually broken their trust. So Dale mentioned something about fast, flexible decision-making or fast, flexible cognition. In this case, this is social cognition, but it seems to be that older adults were showing limited flexibility in shifting their trusting behaviors or their trusting judgment, even though the person had demonstrated untrustful behaviors. The last one I'm going to talk about here in terms of trying to understand what might be happening that increases exploitation risk with age is this idea of reduced sensitivity and arousal to negative cues, something we call in the literature a positivity bias with age. And to put simply, what that means is when an older adult compared to a younger adult is about to make a decision, we all do this. We all weigh the potential risks and the potential benefits of that decision. It appears that older adults overweight the positive possible outcomes, the benefit, and underweight the negative potential benefit. So there's a shift in the weightings that, as you can see, if you think about that for a moment, that would increase risk of exploitation because older adults tend to see the future through a more positive lens and tend to downweight the potential negative outcomes. Again, this is research. I'm not saying this applies to everyone at all times, but this is a general trend that occurs with normal aging. Now, let me put this into a model for you, because remember, our whole idea is developing a surveillance to really surveil to identify who's at higher risk of exploitation. So you'll see we've got the cognitive factors here. This has been very well studied in the literature. We know fluid cognition declines. I just walked you through that. I do think there is a benefit from crystallized cognition, the knowledge and experience. And so the mix here on the cognitive side of the equation can lead to reduced financial management capacity, maybe less optimal decision-making in a financial context. You can also have some fairly straightforward challenges that arise. Things like numericity, things like being able to work your way through a financial allocation or asset mix, for example. So all of these I'm going to throw onto the cognitive side of our model that lead to greater financial exploitation risk. What we believe is perhaps the most important, I've already walked you through some of these, is the social factors. And I want you all to start to think about this because the field has approached financial exploitation risk through the cognitive side of the equation, which makes sense. I mean, we talked about this already today. I think it's not that surprising. What has been missed by and large are these social factors, things like social appraisal, judging if someone may be deceptive, judging if someone is trustworthy, the idea of being more isolated as you age, not having access to trusted confidence to help you make decisions. And then finally, I hadn't talked a lot about this, but in older age, there is a general increase in empathic responding. So if someone is actually trying to sell you something, your friendly bank manager, your friendly investment advisor, older adults will tend to have more empathically based responses. And that is great. There's nothing wrong with that. But I think you can stand back and see that if the intentions of the investment advisor are less than honorable, then this empathic responding may actually get you into a little bit of trouble. So we're bringing this over and saying that the social factors actually increase vulnerability to fraud. And I put interpersonal, if you look at the box from the gray arrow on the right, I put interpersonal and impersonal because we believe it affects both. And remember what I said off the top is that by and large, actually, maybe I didn't say this, but I'm going to repeat it here, and I'll say it here now, is that most of the fraud that occurs in financial exploitation occurs between people who know each other. So someone in your circle, a family member, maybe a caregiver, maybe, as I said, the friendly bank manager, what have you. Most financial exploitation occurs between people who know each other or with a known other is how we phrase it. So we believe these social factors come into play in a very big way in those contexts. So, and each of that leads to financial exploitation risk. So there's one piece that I'm missing that I promised I would talk about when we were mentioning our surveillance. So this is all about surveilling, identifying who is at greatest risk. And those are the age-related brain changes. And Dale walked you through that. Again, it was a beautiful description of what happened in the brain as we age. And what we have done in our own laboratory, in my laboratory, and working with Dr. Sprang, or Nathan Sprang, is we ran a study that, and I'll tell you about it before I show you the data. About 4 years ago, we recruited a group of older adults who had experienced financial exploitation. And we recruited a matching group, a control group of older adults who had been exposed to an exploitation event but had avoided the exploitation. So one group was exploited and one group was not exploited. And we were very interested in seeing, is there something at the level of the brain that might be different, that might differentiate these two groups? And now I'm going to show you the data. So what you see here, it's a very simple image. This is a brain. It's the cortex of the brain. And the front of the brain is over to the right. And then the back of the brain is over to the left. And I think, again, Dale has done a great job in describing the structure of the brain. And we are going to talk about structure here. So we did look at brain function, just as Dale was doing in his studies. Here I'm going to tell you about structure. So this is cortical thickness and how thick the cortex is across the cortex. And we compared both of our groups, the exploited group and the non-exploited group. And we identified differences in the brains of the financially exploited older adults. And these are the areas in yellow here. I want to highlight this area in particular. This is the anterior insula of the brain. As with all brain regions, they do many things. So the anterior insula does many things. But one of the things that we know it is involved in is giving you a sense of your internal body states. So what is going on in your inside, that gut feeling. In other venues where I presented this talk, I described it as the spidey senses. That feeling of, something might be going wrong here. There's something not right. This region of the brain, the anterior insula, is involved in decoding and processing that feeling. And I kind of colloquially here call it the feeling of risk. And so in those group of adults that have been exploited versus those that avoided exploitation, we actually saw a difference in this region. So it really fits with our model of that cognitive changes, social changes, underlying brain changes that are actually having an impact on whether older adults are falling victim to exploitation versus avoiding exploitation. So this is my last slide, and I'm going to talk about where we come. So I said my roadmap is surveillance and intervention. So that was our surveillance part. We're looking at what's going on cognitively. We're looking at what's going on in social functioning. We're looking at what's going on at the level of the brain. And we're bringing all that together to do risk profiling. And that, as I mentioned here, is to uncover comprehensive vulnerability profiles. And why do we do that? We do that so we can develop targeted interventions to help those who are at greatest risk avoid exploitation. And then one of the things that we're doing, and this is early days, but one of the things that we're able to do based on these risk profiles and then target those who are at greatest risk is something we call on-the-spot warning. And that's developing a tool, and this would be particularly for online or email scamming, and we call the tool Merlin. That's why you see a picture of Merlin there. And that tool is effectively something that a piece of software, you can think of it as kind of like your virus protection software. In your virus protection software, what you have is it warns you that there's a potential virus. Here, what we're hoping to do is to warn older adults who are at higher risk, heightened risk for exploitation, that something in the email is deceptive. So we're identifying categories of deceptive cues, and then as soon as that's detected, the software will alert the person who's reading the email. And that's really important, and I'll tell you why that's important. We are running a study, we call it in the wild, so to speak. So we're running it with older adults in their everyday lives. And what we do is we recruit them in, and unbeknownst to them, we send them spam emails over the course of about a month. And in our early data collection, and these spam emails include a link that they can click. In the real world, this would actually be a bad thing to do. In our research study, it's harmless. However, in our early data, 40% of older adults, where we sent those emails out to them, have clicked on the link. That's 40%. 4 in 10 people have clicked on a link that would have infected their computers, for example. So we think this idea of on-the-spot warning is becoming increasingly urgent and important, and it's something that we're kind of building based on all of our surveillance work. So I am over time, as I knew I would be, but I'm going to end here, and I'm going to thank you again for your attention, and I will turn it back to Suzanne.
Fantastic, Gary. That's awesome. I love the spidey sense in the brain. I didn't know that. That's really cool. Well, I'd like to thank all of our speakers. I don't know if Dale can actually come back. He's having trouble. His video and his camera are gone. I don't even know if he can hear us, but we'll just hope he joins us. That's all. And I think it's time for some questionable news. Darn, darn, darn. This is a little game that we like to play to see if you can find the real headlines and determine which ones are real and which ones are fake. So it's now up to you. Now, of course, you can also, in the audience, you can also vote if you like. So we're going to show you something, and then you have to say whether it was true or whether it was an actual headline or whether it was fake. And the first one is, scientists successfully reverse human aging process in breakthrough study. Here's Dale.
All
what
right.
do you think?
Do we vote?
Yeah, what do you think? You have to vote out loud, though.
I'm going to say fake.
What do you think, Fran?
Ooh, that's tough. You see that headline all the time, but I'm going to say fake as well.
What do you think, Dale? Can you hear us?
I'm sorry, I got kicked off, technology problems. I'm back, but I missed the question.
Okay, do you think this is fake or real headline?
Okay, scientists successfully reverse human aging process in breakthrough study. I think I'm going to say false.
Oh, see, it's really a true headline.
We're all such cynics.
Yeah, you know what? I found
I
it this
know.
week, actually. It was awesome. So it's this Israeli study where they put people in a hyperbaric chamber and gave them pure oxygen. And it was 90 minutes a day for 3 months. And they found, it sounds crazy, but they found that their senescent cells decreased by up to 37% by the end of the trial. And their telomeres, which, as you know, their telomere length is correlated with aging, actually increased. So they looked the equivalent of 20. They didn't look, but their cells looked the equivalent of 25 years younger after 3 months. This is a study that just came out this week. So yeah, I know, Fran, you're right. We see this all the time. It's like, oh, we're reversing
They
aging.
can make me look 25 years younger.
So, but it is kind of questionable because we don't know what the long-term effects are, and it was a pretty small sample size. There are only 35 people.
Right.
They're all over 64. And you just know,
see it a lot. Yeah.
and you just know, Gary, that someone's out there who's going to be phoning in, offering you a hyperbaric chamber now. For sure. So,
Yeah, absolutely. That's right.
but still, it's a real headline. Okay, next one, Carrie. Okay, do these 3 things every day to avoid Alzheimer's. Fake or real?
Oh, I think that's real. Yeah, I think you see that a lot too, I think, right?
What do you think,
certainly
Fran?
see it a lot. Whether it's actually true is another question. I don't know.
Agreed. Yeah, I agree with Fran. And it depends on what they are.
Depends which
I'm like,
I'm going to third that and go with it's probably a real headline, but who knows?
It isn't. We made it up. Ha ha.
I'm sure we can find it somewhere.
I'm sure.
Yes, I'm sure. Now someone is writing that article as we speak. Absolutely. Okay, next one. Too much exposure to blue light may fast track aging, even without eye contact. Fran, this should be one right up your alley.
I'm just going with what Fran says.
You will see that. It's a topic of great debate in the field. So I will say true. True that that's a headline. Complicated story as to whether you should believe it.
What do you think, Dale?
I'm going to agree with Fran. And
I think we all
I think it's a real headline.
It is a real headline, but it was done on fruit flies, and they got 12 hours of blue light. So, not quite sure that that is a headline.
You don't want 12 hours. You just want it in the morning.
Much better. See, you should be writing the headlines, Fran. Thank you. But it is a real headline. Okay, no to dementia. Drink red wine, eat dark chocolates, and other flavonoid-rich foods.
Oh, well, I'm all for it.
Yeah.
I'll buy that. I think it's real.
Yeah, I hope it's real
agree.
too.
Yeah, I'm just hoping it's real.
I'm going to believe it whether or not. Yeah.
Exactly. Yeah, I think we're upvoting on that, and it in fact was a headline. So red wine, dark chocolate. I don't even like dark chocolate. It's a shame. I'm hoping that milk chocolate has
We'll just send it my way.
Okay. But again, it's kind of questionable. They studied a bunch of adults who were over 50 for 20 years, but it's all self-report, right? So
Yeah.
no, but it is absolutely a real headline. So good job.
No.
So we have so many questions coming in. Oh dear. So I'm just going to pick one. Okay. I'm going to pick one for Dale because you were kicked off. What's the current evidence on using computer brain training platforms like Lumosity, which I see ads for all the time,
All the time.
Happy Neuron, to improve cognitive functioning and to generalize benefits to daily function? What do you think? Are they real things? What do they do? I've never been opened up at Lumosity.
Yeah, that's an excellent question, and it's very specific. And in a longer talk where I'm going to be presenting sort of the stuff, the work that I did with neurofeedback training, I would absolutely delve into that. There's been an incredible amount of controversy around brain training games. And I'll just name one by name because it was already put in this question, like Lumosity, for example. And so the idea was that they had, these are things you can download or, pay per use service. And they claim to help you sharpen different aspects of cognition. And so you're engaged in some sort of a game that, that it changes based on your performance. And the thing was that they were making claims that, obviously, it's, like I said before, when you go to the gym, it's not just to get better at lifting weights. Usually you want to, getting better at lifting weights makes you healthier and stronger in your life. So the thing was that there was a huge controversy and a big legal battle, actually, where some of the brain training companies were making claims of generalizability of their findings. So sure enough, people get better at the game and better, and that is rewarding, and it feels like you're gaining expertise, and you are. But the fundamental question is, does that actually translate or generalize into any other aspects of life? And there's very little evidence on it. At the time, there were some studies pointed to by the companies. In the end, there was actually a huge fine leveled towards one of the companies, probably the major one, for false claims, that they did not have any actual evidence of generalizability. There was actually a very big consensus statement from a lot of the big sort of scientists, well-known academics and scientists in the field of cognition and memory and aging, who came out and made a claim that these things were not well validated. And so that is precisely what I'm not trying to do with the neurofeedback training. The idea with the neurofeedback training is indeed you get better at this little interface. You get faster and faster at riding your bike through the mountains with your mind, right, your brain. However, what we're showing are changes on unrelated or related, but different sets of kinds of tests. So we're doing standardized neuropsychological memory tests and tests of attention and tests of mood and things, and looking pre and post training. And that's where we're seeing differences. So the evidence that we have so far relates to generalizable effects. More work is being done with the brain training games, but I think that the weight of evidence is still very paltry for those.
Did they ever contact you about these brain training places? Did they ever contact you to say, hey, help us make our game better?
No, but the company that's developing the neurofeedback training came to me, and that's why I'm involved in this project. Yeah. This is a company that said, we've got something we think works, but we want a scientist to take it, do an independent double-blind validation experiment, and to let us know if it works, which is probably the right way to do it.
Well, that's what you want to hear, is that somebody who wants you to do that, doesn't just want to make money. That's fantastic.
And I don't think there's much out there. There's any sort of apps like that really have a solid, demonstration of generalizability. So,
yeah, I think that's the issue.
Yeah.
Fran,
Yes.
Vision is important to everybody. Obviously, lots of questions about this. You did mention cataracts a little bit.
Mm-hmm.
If somebody can't get cataract surgery now because of the pandemic or because of whatever, does this cause permanent problems, or do those problems go away once the cataract surgery's happened?
No, if you're an older person, the good news is, well, your vision may get worse while you're waiting for the surgery, and so you have to be pretty careful during that time. This is when you're susceptible to, falls and things like that. But no, your underlying retina will not be affected by that, unlike a baby where it would be. So the good news is that once you get that surgery, you're going to be able to see again and see quite well. So that's not something to worry about. Just be careful until you can get it.
Yeah, I thought the idea of having lights on inside the house, that was a brilliant idea, so that you can actually get more contrast. That was great.
Yeah, well, falls are the thing we want to worry about, not what's happening to our retina in the case of cataracts.
Cool. This one, I think this is probably for you as well, Dale. And then I'm going to ask Gary one. Here's your question, Gary. What do you think is the best way to avoid fraud or scams?
So I would say right now, the best evidence, I've kind of been working with people, actually surprisingly in the legal community, who deal with a lot of the repercussions of financial fraud and scams and whatnot. And one of the best pieces of advice, so we're coming at this from a cognitive and a social perspective, as I said, and a brain perspective, but I think there's two pieces of advice I would give. One is, I mentioned it during my talk, is to always have someone who you trust around you help you make that decision, if it's a big financial decision. So I think that's really critical. But even more than that, there's it's kind of part 1A and part 1B. The B part of this is you actually should always have two people. And this is really important. And those two people should be from different parts of your life. A family member and a friend, a trusted coworker, a trusted, someone, so that you can always run these decisions by two separate people. Because remember what I mentioned, a lot of actually the vast majority of financial exploitation happens from people you know, and within family quite often. So the idea of having like the buffer of having two trusted advisors, so to speak, is really important. And I'll just say the other aspect is take your time. So in my work, I teach a strategy called stop, relax, refocus. And the stopping idea, to pause, is so fundamental to any decision making. But one of the things that scammers use, I'll just use the term scammers, people who are kind of going for fraud, is they use high pressure. They want rapid response under high pressure conditions, and no one makes a good decision, obviously, under high pressure. And I think the ability to make the best decision is not going to happen when you do it fast without pausing. And so I would say those are the two things. Have a trusted cohort of advisors, so to speak, and then also stop, relax, refocus. Don't let someone pressure you.
Yeah, I think that salespeople have been doing that since the dawn of time, right? Just got to make the decision today or you lose the deal. So
tomorrow.
yeah, anytime you do that, there's a red flag.
Yeah,
I think, Gary, this is related to what you just said, so I'm going to ask this question. So as you noted, the impact of social isolation and loneliness impacts all of the research. So as the so-called benefits of aging independently or aging in place might not be necessarily the goal, right? So is research or work beginning to grow regarding how to develop and maintain interdependence and intergenerational communities and connections, which you need if you're going to have trusted advisors to help you out?
It's absolutely, and that's kind of one of the biggest in the field of exploitation, one of the biggest risks of social isolation, right? Like you're not being able to access your trusted advisors and whatnot. So whether we're moving in this direction, what I can say is that there is a movement afoot to actually have people age in place together. And so the idea of setting up homes homes and living communities and where older adults are able to come together and live together, right? And it sounds kind of maybe, I was going to say communally, but it's the idea is that you still retain your independence, but you set up a culture of looking out for each other. And there's actually been kind of I think a fairly strong move afoot to move in that direction. And so in that regard, you actually get the best of both worlds. You get the age in place, of course, and maintain your independence, but you also set up a community around you. So I think that's the general direction I get from the literature.
So it's Golden Girls then?
It's more or less the Golden Girl.
Well, who doesn't want that as a role model? That's fantastic.
The Golden Girl with snow in Canada.
Sometimes that can be a virtual community too. I mean, there is interest in doing that because the downside of the live-in community we're seeing right now with retirement residences and places where people are locked down more than the rest of us so in times like now, that can be a difficult problem. So
right.
I think a lot of people are weighing these things right now in terms of how would I want to live.
I agree with that, Fran, actually. And it's kind of a nice way of turning our fatigue with Zoom and online things a little bit toward the positive, right? That ability to build a community online is as important. Yeah.
And it's pretty incredible if you think what you can do. I mean, you can take dance lessons and, learn how to cook, do everything that way. So yeah, without any danger.
And Zumba class.
Yeah, Zumba. Fantastic. Okay, Dale, here's a question. You ready? Are you ready?
I think I'm ready.
Why does the default part remain so active in seniors when the attention part is activated? How could a person reduce that so as to more effectively deal with the attention challenge?
Yeah, see, that's a right on point question. So this is what we're trying to figure out. We've got a bit of a chicken or an egg situation in our hands. There's an idea, and some of this is seminal work that Gary Turner and colleagues have done, showing that it's not just about our failure to sort of suppress this network, but that we're actually engaging with our control network. It seems that older adults are either stuck focusing or intentionally focusing more on their semantic knowledge and their, maybe this is that, fluid cognition declines with age, and so we rely more on our stored knowledge and our wisdom, accumulated wisdom. But I think the point is that there are situations where doesn't serve you well, right? Paying attention, remembering where you put things, the fluid kinds of cognition things, altering your path when you're driving somewhere, when there's a detour and you've got to get there. Anything that's flexible is important, and particularly out there in the real world. And so, why does it stay on? I think we don't know that. And so, one of the ways we're using non-invasive brain stimulation now is to say, it's one thing to scan the brain and say, wow, the more that people sort of rely on their semantic cognition or their crystallized cognition and show declines in their fluid cognitive abilities, the more we see this brain pattern. But that's a correlation. We don't know one's causing the other, right? But now we're getting in there with non-invasive brain stimulation, saying, okay, well, let's tamp the default network down. What happens? Do they just sort of lose access to all this wisdom they've developed and all this semantic knowledge, or now they're able to focus and do tasks at the ready and focus on the external world more? We're doing that right now. In fact, we're not right now because of the pandemic. All our labs are closed. But we're in the middle of doing that up until May. But I guess how can you do that? Well, I think that, my guess would be, and Dr. Turner might be more the person to ask about this, but different kind of cognitive interventions where you're practicing being more engaged and relying on your control systems, doing things that are new, require new associations, new experiences, flexible thinking. And that's quite a bit different than saying, well, let's try and do it top down. Let's try and go in and modulate the brain activity and see if that improves it. That's something we're working on as well. So hopefully I'd be able to answer that question with soon. Just order a headset in our software, and you can.
It's pretty cool. Have you had TMS? Have you experienced it?
Absolutely, yes. Yeah.
What does it feel like? Does it feel like anything?
No, it doesn't. It depends on the sort of strength using. It might feel a little bit like just little taps on the head. What's interesting is as we know, there's a piece of the cortex, a strip here, that has a homunculus, right? A representation of all the body parts. Or if we used to see these in the Canadian Heritage commercials, where if you poke a part of the brain here, it can cause a movement in the hand. If you poke another spot, it can cause a movement somewhere else or a sensation. So if you do TMS over what we think of as the hand area in this part of the brain, it'll make. So if I'm to zap, unofficial term, use TMS in this part of my brain, it makes my hand move. And if you move it enough, it can make your arm move. If you move to another spot, it can make it hard to speak. So it does activate the neurons underneath, and you can feel that. But when you're doing other regions that don't have a direct sort of one-to-one correlation with movement or sensation, you don't feel anything in your body. You might just feel a little bit on your head just from the the coil. It's not aversive.
It's kind of creepy.
Cool. Yeah.
I don't know.
Possibly creepy, but yeah, it's fun.
It's great and good. I'm glad you're doing it, but still. Okay, so this is one for you, for Dale and Gary, because it's really about fluid cognition and crystallized knowledge. So, does decrease in fluid cognition affect the development or formation, which you just mentioned, of crystallized knowledge? What are some ways to maintain the ability to draw from crystallized knowledge?
That's a good question, a tough one, and I'm going to punt to Gary on that.
So I think that's such a great question, and that is getting to the heart of where I'm going kind of with my research program. So it's the idea, and not many people bring this up. So it's such a great question because I'm interested in the intersection between these and how they interact. So Dale put up a really great slide that showed some things go up and some things go down, and that's fluid and crystallized. But we call it the shifting architecture of cognition. And so as you move into later life, you do have a preserved crystallized and decreased fluid. So the ability to leverage your crystallized knowledge in a fast, flexible way declines, to use Dale's term. Right. So the idea here, my thinking, and this is a little bit opposite of the question, but my thinking is that the relative gain in crystallized knowledge as processing declines, like fluid processing declines, is actually further driving that decline. So I actually think there's a almost a negative loop. So because you have the answer, so to speak, the wise answer, right? Like based on your crystallized knowledge, you may not go forward to find a more adaptive response, a more adaptive answer, and challenge your fluid abilities because your crystallized knowledge is sitting at the ready. And so I think the intersection fits in that way. So it's a little bit opposite. So the question was, how can you use your fluid to access your crystallized, I believe. And
Yes.
so I would say it's actually your crystallized knowledge is almost always at the ready. One of the big challenges, I think, with cognitive aging, at least as I'm starting to think it through, is somehow suppressing your access to all that crystallized knowledge that rushes forward and then does not allow you to be fast and flexible when you may need to be, right? So of course that's fantastic. All this knowledge is sitting there. And for the most part, that's amazing. Like that's great. That's what wisdom is, right? But sometimes it's not amazing when the context changes or when something happens, right? So the ability, and this comes back to Dale's work on the network idea and the earlier question, I think, that idea of kind of suppressing that default network, which actually brings, I would argue, brings forward a lot of this stored knowledge representation. And so dampening that down with age is probably a good thing in the context where you need it. And remember, more knowledge and lived experience is a very good thing. So that's really not a bad thing. It's not always good. So I think that's kind of the interesting part about this. So yeah, it's a great question.
Actually, it leads to, oh, sorry, Dale, did you want to say something?
I would do a very quick follow-up and just say I absolutely agree. I think that was really well put, Gary. And to summarize, I think what the way I would interpret is sort of you have to be careful not to get too stuck in your ways, right? As you get older, ingrained in your habits and what you know, and forget that there's, or to lose your ability to consider the alternative and be flexible. And I think that's the challenge.
Yeah, it's an idea of stickiness, we call it, another good scientific term, like this idea of kind of being, but to that point, just a last quick point, is that this stored prior knowledge does have a certain gravitational pull. It's readily accessible and always at the ready, right? So it's important to think about that, and what that means for your ability to bring on your fluid cognition.
Cool. It kind of relates. So we had a viewer named Mary who sent email a lot of awesome questions, and we just don't have time. So I just want to wrap it up with one last thing. And Mary very rightly said, a lot of the things we talked about today are kind of ageist. So we kind of use negative language when we talk about aging without thinking about it, right? We say we're suffering from aging and, oh no, we're getting old, all these negative things. And that's actually kind of true. We're not suffering from aging. We're actually lucky to age. And if we think about who's coming in as the president of the United States, he's 78 years old. So let's hope that there are some good things with aging too. So maybe each of you could tell us some good things that are happening as you get older. And also, do you think that we are ageist? I kind of think we are an ageist society. Everything is about looking younger, being younger, staying younger. Your ultimate compliment is when someone says, oh, you don't look your age. So, it's kind of weird. What do you think, Fran?
Well, I definitely think we're an ageist society. I teach courses to older people, and one of the things we always do is try to figure out what terminology we want to use for ourselves. It's very hard to get people to agree on that, because most of us don't like seniors, elderly, or any of those other words. Older is generally okay, although people can come up with lots of other choices. I think we have to be aware of that. We certainly live in an ageist society. We don't want us older people to be ageists ourselves. And I think we're all aware of changes that are happening, but they're not all bad changes. And I think the things that we seem to lose, like it's always harder to find names now, but we gain a lot of other things. As Gary said, positivity is one of them. Things don't bother us nearly as much. So I think there's a lot of positive things we can see in aging as well.
Agreed. What do you think, Gary? I know that is part of what you're looking at.
So I would say that I love being called out on this because it's so endemic. So I think we are a completely ageist society, like fully, like no, I have no dispute with that at all. What I really try and do, hopefully I was doing it through this talk and through this session, is there's so much great in aging. Like there's really, you are gaining all the knowledge, you still retain your ability to use that knowledge. It's amazing in terms of the wise aging. And so a lot of my work, so I always put up a slide in like a moment in when I go and teach my courses, and it says the idea of aging is like a straight line down, right? And so then you kind of bring in the graph that Dale showed and whatnot, and you say, no, that's not true. Like, sure, some things decline, like obviously, but there is a lot of gain that occurs with aging. And it's both cognitive gain that I talk about, Dale talked about, and what Fran just brought up, social gain, right? That ability of social, emotional functioning, being more positive about the future, kind of taking in something that's more positively valenced or what have you. There's really like a lot of what gets me excited about doing this work is the positive and trying to push back as much as I possibly can against this ageist approach to almost everything. Like it's endemic. It's hard to fight back.
It is. And, you mentioned empathy too, and that people would try to take advantage of the fact that you get more empathic as you get older, when in fact that's a lovely thing to be more empathic. And
it's
yay.
Wonderful. Yeah, exactly. And more trusting. Like who doesn't want that? Like it's wonderful, right? So this is a great question, really great question.
What do you think, Dale?
Well, I would agree. Great question. Really good point well taken. And I think excellent responses from Gary and Fran. And I would just concur with everything they said, that it isn't, it's a real issue. There's particularly, at least in our culture and our current civilization, our culture, it seems to be too much weighted towards a negative idea of aging, that it's just a negative thing in life, and it just doesn't make sense. I think about different cultures who would rely much more on elders and the wisdom of elders, and the idea that our aging across our lifespan is uniquely set up to do that kind of thing, to retain a lot of knowledge, to be able to integrate a lot of knowledge over a long span of time. That's not something that declines, and so there are good aspects. There are also really interesting cognitive neuroscience experiments demonstrating that some of these changes where older adults perform differently than younger adults actually have side benefits. The idea that younger adults are better at sort of focusing very clearly on something in a task and retaining that information, whereas older adults may not remember as much information in general, but actually take in more peripheral or contextual information. And a bias towards more positive emotions and remembering positive things. Really reiterating what Gary and Fran said. So I agree.
And can I just say one more thing?
Sure.
In these pandemic times, I actually worry much more about younger people who I think are having a much harder time right now. It's a very uncertain time for their lives, and there seems to be a lot of mental health issues in that group. And for the most part, apart from isolation, in some cases, I think older people are coping fairly well at the moment because we don't have all of those stressors that younger people have. So it's not all bad.
Well, that's a good note to end on. Thank you all. Thanks so much, Gary, Dale, and Fran, for telling us all these fabulous things and helping us all embrace getting older. It's inevitable, so let's embrace it. Thank you.
Thanks
to you, and thanks to you in the audience as well. We hope you enjoyed the discussion today. I certainly did. Please share your feedback with us and let us know what you'd like to see from us in the future. There's a link in the chat box so you can share your feedback. We will be back in the new year with a look at your brain on stress and uncovering the mystery around fast radio bursts, which are really weird. So I'm excited about that one. You can get details on all of our upcoming events on our website, rciscience.ca/what's on, also in the box. And on the website, I actually found this on Friday. We have a Canadian gift guide. It's a fantastic gift guide if you're a science or math nerd and you want to buy stuff, or you want to buy stuff for a science or math nerd. There's some really cool ideas there. So please do go to our website and you can click on the gift guide. And I already ordered several things, so the link should be in the chat box as well. So thanks to everybody for joining us. We wish you a safe and happy holiday season. Stay well, stay safe, and see you in the new year. Bye.